Hello everyone, welcome back to the online sessions of the Material Science and Metallurgy. Myself Vivek Parikh taking the lectures on the non-destructive testing. So, we have already discussed about the different types of the NDT methods in which we have discussed about liquid penetrant testing. Then we have gone for the magnetic particle ultrasonic testing. We have also find out the difference between the destructive testing and the non-destructive testing, objectives of the NDT, types of defects which can be find out with the NDT, and which are the different methods of NDT we have discussed. So now there are remaining two methods which are there for the non-destructive test, and out of that let us discuss the thing that is the fourth method known as an eddy current testing. It is one of the most typical type of the testing methods which is there for the NDT method. Now what do you mean by this eddy current testing? So directly we will be going on the principle of the material, that on which principle that this particular method works. Eddy currents are created through a process that is known as an electromagnetic induction method. So what do you mean by the electromagnetic induction? With the help of the magnetism, there is an electric current which is generated. Recall the thing, in the magnetic particle testing I told you, due to the electric current we were producing magnetic field, and in this thing the same thing will be applied. With the help of the magnetism we will provide the current, that is your eddy current we will be generating. When an alternating current is applied to the conductor, such as a copper wire or a magnetic field develops over it and around the conductors, and the magnetic field which is expanding, it will generate an alternate current, and due to that thing what will happen, whatever the alternate current is generated, that is known as an eddy current. Now let us see, if any another electrical conductor is brought between that thing, what will happen? Due to that, inside of that particular second material there will be a current which is generated. So now let us discuss the thing over here, that how does this particular method which is working. That you can see over here, there is a current, there is one conductor, and on this thing what will happen, the current is passing in this conductor. Due to this thing what will happen, you can see over here a circular type of the magnetic field which is generated. Clear? So this is a unique thing which we have already seen in the magnetic particle testing. When current is passing, magnetic field is generated. But over here you can see, if you are taking another conductor if you are taking, what will happen? There is also a current which is developed on it. There is also a current which is developed on this material. How? Due to this magnetic field, your current is applied on this material. Over here, from this conductor, magnetic field is generated. When another component is introduced inside the material, so due to this magnetic field, current is generated, and whatever the current which is generated, that is known as an eddy current. What is eddy current? Eddy current is nothing but one of the loss of the current. Which loss? The loss of this conductor current. Whatever the current loss is there in this thing, the whole loss we can find out, that is eddy current from the which is induced on the another conductor. And this is how your eddy current testing works. Clear? So now how we can generate the eddy current, you all know. In order to generate the eddy current, for an inspection the probe is used, and inside the probe what we are taking? We are taking an electrical thing. This is the coil which we are taking, and in that thing what, this is the coil which is placed inside the probe. Clear? The probe which we are using in the ultrasonic thing. Then alternating current is allowed to flow in the coil at a frequency which we are choosing. So here you can see that the alternating current is applied on the thing. So here we have applied an alternating current field. And then what we are doing? A dynamic expansion and collapsing of the magnetic field. That means due to the current what will happen? The magnetic field will be generated. You can see the blue color magnetic field which is generated. Why? Because your electric current is passing through the coil. Okay. So now when an electrically conductive material is placed in the coil, dynamic magnetic field, the electromagnetic induction occurs, and there is a secondary magnetic field which opposes the primary. And you can see over here that this is your second type of the conductor which is used. This is the second material. So what will happen, this second material will come in between the magnetic field of this blue color. So what will happen, this red color you can see the current will be generated. Why? Due to the magnetic field, the current will be generated on this sample. So on this sample what will be done, this is the eddy current, and due to that thing we will take the advantage of it and we will test the material. Clear? So which are the different types of the instruments which we are going to use for the eddy current testing? The first one, probe or encircling coil. That means a coil which is placed inside a probe. Then why we are using this? Used for the generation and the sensation of the eddy current. Second one, electrical unit we require. Why? Electrical unit they are required for the frequency generation. And the third one, CRT or a recorder screen on which we can find out the recording, or you can say the data will be there on that particular machine. Clear? So for the display unit we are going for the CRT or the recorder. So these are the thing, the probe, coil, any type of the thing, it look like this. That is the probe, and the encircling coil will be like this thing. Okay. Let us move forward for the methods. Which are the testing methods for the eddy current? The first method, that is known as a test using encircling coil. Two coils are used. The coils are allowed to move on the sample and the graph is recorded or noted down. Whenever there is a defect, you can see the variation in the graph where there is a current leakage is there. Okay, so let us see. So this is the thing. So whatever the thing, you can see there is a 3 coil which is there. There is a 3 reading which are there. But whenever this coil comes near the thing where there is a defect, there will be a change in the indication. Wherever you feel there is a change or the change in any of the 3 things, voltage or an ampere, you can find out or you can say that there is a defect inside the material. Why? Because there is a current leakage is there. Clear? You can see over here also, whenever the coil is moving, there is a defect signals which we can see. Whatever the defect is there, it will show you in the variations. And this is how, with the help of this coil, encircling coil, we are finding out or we are detecting the eddy current testing for the non-destructive methods. The second method which we are using, that is by the probe method, that is test using the probe. In this, probes are used and these probes are allowed to move on the surface. And the current is measured and the pattern is noted down. Whenever there is a change, we can observe there is a defect which will be there. So let us see how it appears. So this is a probe on which any of the surface we will be moving this probe on the surface, and there is a detection on the thing. If there is a defect like this, if there is a change in the any of the current, you can find out that there is a defect beneath that surface. You can see over here the probe. We are moving this probe over or we are rolling this probe on the surface, and whenever you find there is a change in the current, you can say that there is a leakage is there, and as a result of which you can say there is a defect inside the material. So that is your test using a probe. Clear? So this was your eddy current testing. But what are the advantages? It is a versatile method where for the various applications we can use. It is having a higher sensitivity towards the material property. It gives you the result, that means permanent record we can find out. It is a very fast method. After calibration, it is one of the rapid methods which is there. But there are also many disadvantages. That means the standardization and the calibration should be compulsorily done of the material. The size and shape of the component is limited because we cannot use a very large components or the irregular shape components. Why? Because inside the coil or that probe, if you cannot take that probe for that surface, you cannot detect the surface. Overall cost of the particular method is very much high, and it is not suitable only for the conducting. That means the polymers or the ceramic we cannot find out with the eddy current testing. Clear? External power source is always required. During the whole process, external power source is required. But Where we can use the application? It is used to find out the size and depth of the surface in various components. Electrical conductivity can also be find out. Sorting of the material by the chemical component. Hardness, heat treatments can be done with the help of this eddy current testing method. And also used to find out the measure of the material thickness, coating thickness, any type of the thickness can be find out with the help of this eddy current method. Clear? So this was all about your fourth method, that is known as an eddy current testing method. Now let us move forward for our last method, that is known as an radiographic testing. What is this radiography? We have used liquid, sound wave, magnetic current, magnetic field, electric current, and now the only thing which is left, that is known as a light source. So here we will be using the light source, in which X-rays and the gamma rays are used for the radiographic testing. Components, they are exposed to the shorter wavelength radiations. X-rays which are having the thing that is 0.001 into 10 raised to minus 8 to 3 into 10 raised to minus 8 centimeter, which is produced by the X-ray tube. X-ray is operated at the 400 kilowatt and is used to only measure up to 62 mm thickness. Gamma rays, which are the radioactive isotopes, they are produced from the radioactive isotopes such as cobalt 60, iridium 192, cesium 167, etc. So X-rays, they are produced in the X-ray tube. Gamma rays, they are produced by the decaying of the radioactive material. And the film which is produced by X-ray, they are known as an exograph, and the film which is produced by the gamma rays, they are known as an gamma graph. Now let us see how or the principle through which your radiographic testing works. In the radiography, X-ray, gamma rays which we are using for the defect. Here components are subjected to the radiation of the X-ray, means they are placed in between where the X-rays and gamma rays are moving. These radiations, that means whatever the radiation, they goes inside the material and comes out from the material. So some of the things, they are absorbed by the material. When these rays passes through the defect, some of the radiations, they are absorbed less. Why? Because there is a defect. So absorption of the radiations, they are less where there is a defect. So what will happen? These radiations then comes out and they are recorded on a screen. And then whatever the screen is there, it is taken in a light and the dark areas we can find out and the defects which are there. It is the same X-ray, that means whatever the bone cracks or whatever the cracks we are seeing in that X-ray, the same thing is applied for the material. So now let us see, this is the thing that your X-ray, your sample is through to this thing. Less exposure where there is a defect, you can see over here. Where there is the material is thick, more amount of radiation are absorbed, so you can see there is a light area. Where there is a small material is there, less amount of absorption is there, so darker areas is there. So over here you can see the sample, if there is, this is the exograph, if there is a defect on the sample, then you can find out the defects which are there. This is no defect, there is a porosity defect, if there is a crack over here, you can see these things on the radiograph or the exograph material. Now, how you produce the X-rays? X-rays, they are established by a very high voltage between the two electrode, anode and cathode. To prevent arcing the anode and cathode, you have to always create a vacuum tube, and it is done inside the vacuum tube. Clear? So here it is the thing. Anode and cathode is there, and here you can see over here anode and cathode are placed, and this is the vacuum tube is there. Done? So now cathode, what will be the cathode? The cathode always contains a small filament which is same as that we are using in the bulb. The small thin filament, that is a cathode. What is anode? Anode is the target on which we want the cathode particles to get fallen. So what will happen? The current is passed through the filament which heats it, and due to the heat, electrons, they comes out. Now this high voltage causes the electrons to be pulled towards the target material. So what will happen? They are pulled towards the target material, which is anode. Your anode will be positive terminal, that's why your negative electrons will move towards the anode, that means your target. The electron impact against the target, and what will happen, this causes your kinetic energy to directly comes to the zero. So whatever the energy is there inside the electrons is suddenly stopped. So what will happen, that energy is converted into radiations. You can see over here in the figure we will be seeing that this is the thing where you can see over here. So normally the X-rays are produced when fast moving. So what will happen, due to the high voltage, electrons are generated. These electrons moves towards anode, which is positive terminal. They strike on the anode. After striking, what will happen, the moving kinetic energy is converted into zero. But whatever the energy which is there inside the electrons, what they will do, they will give away in the form of the radiations, and you can see these radiations, and whatever the radiations they are there, that is known as an X-rays. They are known as an X-rays. You can see over here cathode. Here there will be a thin film will be there, that is filament. Due to the heating voltage, what will happen, the electrons will move and heat towards anode, positive anode. What will happen, here kinetic energy is converted to zero. So what will be done, here X-ray beam is generated. Clear? So this is how the X-ray is done. How gamma rays they are produced? They are produced by taking a radioactive decay of any of the thing. Majorly radium is taken, and whatever the material which are used for that thing, we can take that material and surrounding your sample, radium sample or the radioactive, we are placing the specimen which are to be tested. Cobalt 60 decomposes at a very constant rate, producing a shorter wavelength. A cylinder cobalt 60 source with dimension 3 mm in dia and 3 to 6 in length, they are used to seal that particular cobalt 60 thing. And from the source, gamma rays are emitted and they comes out from that cylinder and goes in all the direction and for the detection of the material. You can see over here the sealed part of the cobalt 60. The sealed part of cobalt 60 is kept over here. So over in all the direction, the radiations will go and will hit the target, and as a result simultaneously more amount of specimens they can be detected at the same time. Now what are the difference between X-ray and the gamma rays? Let us discuss. X-ray, they are having larger wavelength, gamma ray shorter wavelength. So due to the larger wavelength, what will happen, the penetration power is less. They cannot penetrate more inside it. Here penetration power is more. So what will happen, more than 62 mm can be find out. Here up to 62 mm thickness we can only find out the defects. Only one component at a time. Here as we saw, more than one components can be find out, or defects can be find out in more than one component at a time. X-ray equipment, they are larger in size, where they are compact in size. Why? Because only cobalt 60 we are using, so it is a very small amount of instrument is there. Time required, that is less. Here time required is more because the decaying of the element takes somewhat more time as compared to the X-ray. Scattering of the light which is more in the X-ray, whereas scattering of light which is less in the gamma rays. Clear? So this was your radiographic technique. Let us discuss advantages about it. Provides the permanent record, as before 10 years whatever the X-ray you did, that can be find out, or the whatever the data is there we can find out on the X-ray film. Then thin as well as thick sections can also be find out. Very sensitive method. It is used for any of the material, ferrous as well as non-ferrous material. It is a very rapid and a reliable method. That means there are many more advantages of this radiographic technique. Hidden flaws can also be find it out, but there are certain disadvantages. That means initial cost of setup is high, that is machines and all. Skilled operators, they are always required. Very small defects cannot be detected, that means overlapping defect, very small defect that cannot be find out with the X-rays. And the major disadvantage, they are hazardous to health, because gamma rays, radioactive rays, they can create a cancer in the humans. X-rays, if you are much more towards the X-rays, then also cancer is likely to happen in your body. External power source, they are always required for the generation of the X-ray. In gamma ray we do not require any of the external power supply. where we can use this thing used for the inspection of casting, forging, welded parts. Majorly radiographic technique we can go for the welding of the material. Used to detect crack, broken wire, unshoulder correction, foreign material, etc. They are also used to find out defects in the electronic components, in the missiles and the power plants and all. Clear? So let us bifurcate that the radio technique, welding, they are always done in radiographic. Any ferrous material with the help of the magnetic particle testing, any surface defect with liquid penetrant, and the large or the longer type of the sample is there, then we will be going for the ultrasonic method. Clear? So this was all about your radiographic technique, and here it ends your all of the non-destructive testing methods. We have discussed liquid penetrant, radiographic, ultrasonic, magnetic particle, and the last one, that is eddy current testing. Clear? So here it ends your unit, that is known as a non-destructive testing. Clear? So now in the next lecture we will be going for the new unit. Till then, thank you.